sixth graders. Okay, today we're going to be looking at equations. And we are going to be looking at equations that have not one, but two variables. So over the last week, we've been solving equations with one variable. And we've been calling those one-step equations because you've had to do one step in order to isolate the variable by itself. Well, today, we are going to be looking at equations that have two variables. Not one, but two. That's right, two variables. Don't worry, it'll be okay, I promise. Okay, so two variables. That's what we have to work with today. And tomorrow. Okay, so in our lesson, we're going to be studying how to see a relationship between these two variables. How do they go together? So we're going to be looking at, by the end of our whole lesson today and tomorrow, you should be able to write equations with two variables and be able to explain the relationship that that is occurring between those two variables. Like why one happens, what happens to the other variable? Why do they need each other to go together? Why are they together? Okay, so today we are going to focus on ordered pairs. And we know that ordered pairs lead to graphing. So we're looking at graphing today with just the ordered pairs. We're not going to actually graph. So we're just looking at points on a coordinate grid with their ordered pairs. Okay. And we're going to see if we can put those ordered pairs as a solution in an equation using substitution. That was a lot. Oh my goodness, and I'm already tired. We're 2 minutes into the video and I'm exhausted. No, just kidding. Okay, let's go. Are you ready? I am. Let's do this. Okay, so first we need to know what in the world equations in two variables, what does that even mean? That doesn't even sound like math words. I mean, it sounds like math words, but not like language arts words. What? Give me some words, Miss Englander. Okay, so equations, an equation in two variables. This is what you're going to see all over the place. An equation in two variables, that's the vocab term, is just a fancy phrase. So put on your fancy pants. Put those on because this is a fancy phrase. All right, it's a fancy phrase for fancy people. All right, it's a fancy phrase that means two quantities or two amounts, right? Quantities are an amount. Two quantities that change in a relationship. Okay, so you're going to have two amounts that change during the relationship. Now, I'm not talking a relationship where it's either like dating or marriage or love, that kind of relationship. I am talking about a relationship that has to do with something like time. So, for example, time versus like how far you go. So one part is time, the other part would be distance, how far you're going. I can travel this amount of time or this amount of miles in this amount of time. They go together. Their relationship is together. Okay? Or like the cost per hour. Okay, so like how much does it cost to have somebody do that for you per hour? Or how much are you going to charge somebody to do work for them per hour? That's what I'm talking about with relationship. Okay, so maybe I should just give this like a little squiggle. Relationship. Okay, so these two quantities are going to change based on one or the other. Okay, so they're going to change because of one thing's going to change, it's going to make the other thing change. And that's where we have our ordered pairs. Okay, now we would have our solution of two variables would be the ordered pair that we're going to use. Okay, so when we ask the question, is this a solution? We're going to be looking at an ordered pair and comparing the x to the y. What does that mean? I don't remember what that means, what she's talking about. Oh my gosh, I don't know. Don't worry, I'm going to tell you. Quit freaking out on me. It's okay, I promise. Okay. Okay, here we go. A solution of two variables in two equations. Not one, two equations. Okay, so a solution of two variables. Solution of two variables is an ordered pair that makes an equation true. It's an ordered pair that makes an equation true. That is not R. Oh my goodness, my writing today. I am so sorry. Makes an equation true. Okay, so a solution of two variables is an ordered pair that makes an equation true. So what is an ordered pair? I have no clue what you're talking about, Miss Englander. I don't remember this. I totally forgot. So let's talk about ordered pairs. Okay, ordered pairs are the x and the y. It looks like this. X always comes first. It's always on the bottom, and then we go up the y-axis, okay? So it's the point on the graph. It's like an address. It's an address for the dot. Okay, so let's, I'm going to put a cloud around this because I want to make sure that we know what this is, and this goes to an ordered pair. Okay, so this is an ordered pair. Ordered pair. Hopefully that stands out enough. Okay, so an ordered pair is x comma y. It's the address of the ordered pair. Sorry, there's so much vocab. Okay, so we want to know, how do we identify solutions of equations in two variables? So, oh, look at that. What's that? That's an x. What does that x stand for? Oh, we don't know yet. What's that? That's a y. What does the y stand for? We don't know. Oh my gosh, one variable, two variables. Oh my gosh, we're being attacked by variables. Okay, not really. But we have two variables. We're going to use them right now. Okay, are you ready? Let's look at our first example. Okay, example A. I have something that looks like this. Y equals 2x. What? Are you crazy? How am I supposed to solve this? This doesn't even look like a full math problem. Oh, guess what? It is. Because, guess what? I'm going to tell you that this has an ordered pair attached to it. And the ordered pair is 3, 6. Oh, okay, well, this does not look so bad now because I can tell you right now which one is the x. The x is always right here. It's always that one. See, it's right here. It's always the one on the left. That is always the x. Then the y. Get it? X, Y, then Z. Z isn't in here, so don't worry. We don't have a Z. But we do have an X, and we do have a Y. Why? Because it's math. That's why. Okay, here is the Y. Okay, oh look. Here is the Y. Imagine that. Okay, we are going to use this X and this Y. You know how to substitute when you have a letter for a variable. And you know how to check solutions. And we're going to do just that. Let's do it. Okay, so our first step. Balance line. Always the balance line. We want to make sure that this side is equal to this side. If it's not equal, it's not a solution. Okay, it goes back to when we looked at solutions in 6.1. Here we go. What is a solution? It has to be equal, right? Not a solution. Not a solution. Oh, look, it's a solution. We want those notes to stay with us. Okay, here we go. Y is equal to 2x. So we know that y has to be the same as 2 times x because the number stuck to a letter means multiplication. All right. Here we go. So x. I'm going to rewrite this side of the problem to say 2 times 3. 2 times 3. And we want it to be equal to 6 because on this side it said it needs to equal 6. Well, we know that 2 times 3 does in fact equal 6. So if y equals 6, oh, I just got backwards here, sorry. If x equals 3 and y equals 6, then this ordered pair of 3, 6 is a solution because 2 times 3 is 6 and y was 6 the whole time. So we just write 3, 6 is a solution. And it's a solution to the equation. If it's not a solution to this equation, then we would say is not a solution to this equation. Okay, let's do another one. Okay, B. Example B says y equals 4x. Where 4 is x and 12 is y. Okay, let's do our letters here. X, y, no z. Okay, so where I see my x, I am going to put a 4. Draw my balance line. Okay. And I know that 4 times 4 is 16. Now, let's go to the other side. Y. Y was supposed to be 12. 12. 12. Ooh. 12 is not equal to 16. So guess what we get to do to that? We get to whoosh, slash it, whoosh, chop it. You put a slash through it because it means not equal to. So 12 is not equal to 16. This means that when y equals 12 and x equals 4, this is definitely not a solution. It is 4 too small. So we would say 4, 12 is not a solution to this equation. It is not. It's totally not a solution. No. No, thank you. Not a solution. Okay, I want to do another one of these, but I want to do one that you might see that looks a little bit funky. Okay, so letter C. And then I'm going to give you a try it. Okay, letter C. Y equals, when you get to like 7th grade and 8th grade, you're going to be hearing this as y equals mx plus b, and it's actually getting you ready to do the slope of a line. That's what this is doing. But shh, I didn't tell you that's where we're going when you're like a 7th and 8th grader. Okay, so y equals 2x plus 1. But wait, there's more. Yep. Okay, balance line. And this is when x, nope, I did that wrong, sorry, and y. Let's just go like that, okay? Now, x is equal to 3. No, it's not. I'm looking at the wrong problem. Oh my gosh, Miss Englander. X is equal to 2. How many mistakes are you going to make in this one thing? Are you qualified for this lesson? Yes, I'm fine. I promise. It's just late. It's a late night. Okay. 2, 5. Okay, we know that this is the x. Just color right over that. Pretend that happy mistake didn't happen. Or we learned from it, right? Okay, x and y. So we're going to take this x and we're going to pop it in right here. We know a number stuck to a letter is multiplication, but then there's extra. Got a little extra baggage here. We're just going to add that right on at the end. So 2 times 2, that's 4, plus 1, order of operations. It's okay. 4 plus 1 is 5. Okay, check it. Y was supposed to be 5. So is 5 equal to 5? Yes, it is. Woohoo! We did it. So we would say, what would we say? We would say 2, 5 is a solution. It's a solution, folks. We got it. We solved it. Oh, yeah. All right. We're going to do a try it, and I feel like I need to go on to the next page. I know I have this space right here, but if I do it right here, then you don't have any space to do your 2 try-its and any essential questions. So I'm just going to turn the page. If you don't need to, don't. Okay. Oh, fresh paper. Here we go. All right, your first try-it. Your first try-it is try-it number 1 says to us y equals 7x when x equals 2 and y equals 21. Your second try-it is y equals 5x plus 1 when x is 3 and y is 16. Okay, ready? I don't know why that's so big and that one's so small. Okay, ready? Here we go. Pause the video or you're going to hear me do this. So pause it. Right. Yeah. Okay. X, Y. All right, draw my line. I know 7 times x equals 2. So I'm going to put the 2 in for x, and that gives me 14. So it said y equals 21 and y equals 21. 21 is not equal to 14. Just like that, slash it. So 2 comma 21 is not a solution to this equation. It is not a solution to this equation. Try again, folks. Try it again, buddy. Give us something better than that, something that actually works. Okay, here we go. Next one. X equals 3. Over here we have y, and y equals 16. So I'm going to put 16. I want 16 to be equal over here. I just filled it in because it was easier to do that. Okay, now I know this is 3, so I'm going to say 5 times 3 plus 1. I know that this is 15 plus 1, and 15 plus 1 is 16, and 16 is equal to 16, so we would say that yes, they did it. They got it. 3 comma 16, this ordered pair right here, is a solution to this equation. Woohoo! And then you would hear like all the cheering and the clapping, and I just dropped my pen again. Okay. Essential question. Answer it. How do we identify solutions to equations in 2 variables? How do we identify if it's a solution or not? How do we know if it's a solution or not a solution to this equation? You got 2 variables. What do you do with them? And off to the side, put your rating in your little box. 1, I'm still back where you wrote, 2 variables. I have no clue what you did, Miss Englander. I'm going to come to the Google Meet. 2, I am going to, I'm okay. I'm kind of in the middle, kind of not in the middle. I'm totally lost. So, or not lost, just kind of somewhere in the middle. I'm going to ask questions because I need some help, but I also know that I'm going to get it with more practice. Or 3, I totally get this. I'm just using substitution. That's it. Just plugging away, plugging numbers in there, solving. You tell me where you're at, put it here, tell yourself where you're at, so that tomorrow when we do this in class or on a entry task, you're able to help explain this to others. Okay, and as always, Cougars, make it a great day the Cougar way!